arithmetic operations. Now, first we'll show you in how to execute arithmetic operations in series, and then we'll show you how to execute arithmetic operations in data frames. Okay, let's create two series. One is S1 PD dot series. This is how you are going to create the series. Okay, and these are the elements like 7.3 minus 2.5, 3.4, and 1.5. And this is index. Index means the rows, right? Row indexes. You're defining like index will be A, C, D, E. So for this value, index is A. For this value, index is C. For this value, index is D. And for this value, index is E. Okay, that's series S1. And if you define another series S2, PD dot series minus 2.1, 3.6, minus 1.5, 4, and 3.1. Here, suppose we are defining the indexes as A, C, E, F, G. Okay. For the first series, just have a look. The index are A, C, D, E, and second series, the index are A, C, E, F, G. So D is uncommon between these two. D, F and G are uncommon, and A, C, E are common. Okay. Now, if we want to sum these two series, let's say S1 plus S2, how to be done is, okay, basically it will go index by index. Okay, it will check whether first it will check A index is available in both the series, right? So what it will do is it will take value from A index from S1 series 7.3. Okay, I have not called it. Okay, check the error because it says name PD is not defined. What happened? I did not execute. I did not import the pandas and numpy. That's why it was giving error like name PD is not defined. Now if I execute it, it will be running successfully because now I have already imported the package, right? Okay, so how the summation works? First, it will check the index A in series one and take the value 7.3, and it will take index A value from series two, which is minus 2.1. So 7.3 plus minus of 2.1, that means 7.3 minus 2.1 is 5.2. Okay, see the output for index A is 5.2. Now it will check C. Okay, C index value from series 1 is minus 2.5, and C index value from series 2 is 3.6. So minus 2.5 plus 3.6 is 1.1. So that will be placed in C. Now check D here. D index is there in series 1, but D index is not there in series 2. Okay, so in Python, like value plus null, this is null because D index in series 2 is null. So value plus null or null plus value or null plus null will be null value. So D is null value. Check it here, right? D is null value because D index is available in series 1, but D index is not available in series 2. Okay. Similarly, say for E index, value will be 3.4, and E index value from series 2 will be minus 1.5. So 3.1, 2, 3, 4. Okay, so let's execute it.
It's
E index,
1.5 minus 1.5.
yeah,
E is
sorry.
1.5.
So this is 1.5 minus 1.5 E. Okay, that's why it is 0. Okay, then it will check F and G. So F element from index series 2 is not available in series 1, right? So again, null plus value. So null plus value will be 0. I mean, will be null. And for G also, this index is not available in series 1. So null plus this value, 3.1. So null plus 3.1 is null value. Got it? Clear? Now, let's say we are going to execute this operation, plus operation, in a data, in two data. Yes, go ahead. Any question?
Can you repeat again, please?
Sure. May I know who is this? Is it Prashant? Okay. So basically, suppose I'm going to create two series, S1 and S2. Okay. Index for this series is A, C, D, E, and index for this series is A, C, E, F, G. Okay. So if I do S1 plus S2, how it does is it checks all the indexes one by one. First, it goes through A index. A index is available in both the series, so it will take the values from A index from both the series. So 7.3 plus or minus 2.1, so which is 5.2. This one. C minus 2.5 plus 3.6, which is 1.1. D D index is available in series 1 but not available in series 2. That's why value plus null, I mean 3.4 plus null value from series 2 is null. So for D it will be null. For E index, the value from a series 1 is 1.5, and for index value from series 2 is also, I mean, is minus 1.5. Okay, so 1.5 minus 1.5 equal to 0. That's why for E index the value is 0. And for F and G index, F and G index are available in series 2, but it is not available in series 1. So null value plus value, some value. So null value plus 4 is also null value. Null value from series 1 plus 3.1 value from series 2 is null value. Clear?
Got it. Yeah, thanks.
Okay. Now let's say we want to execute plus operations for two pandas data frame. So we are going to create np.arrange. You know, like np.arrange means it will take from 0 to 9, and then reshape 3 comma 3 means we are going to create 3 cross 3 matrix. Okay. We are going to define the columns. Columns equal to B, C, D. I mean, columns for this DF will be B, C, D, and columns for uh, DF2 will be B, D, E. Okay. And index for this data frame is Ohio, Texas, and Colorado. Index for data frame 2 is Utah, Ohio, Texas, and Oregon. Okay. So check what are the common things. Texas, Ohio and Texas are common, and Colorado, Utah, and Oregon are uncommon. Okay. Now if I print it, and DF2 is nothing but range values from 0 to 12, and the shape is 4 cross 3. So 3 cross 3 and 4 cross 3. 3 rows, 3 columns, 4 rows, 3 columns. So this is the DF1, this is the DF2. DF1 has Ohio, Texas, and Colorado rows, B, C, D column. DF2 has Utah, Ohio, Texas, and Oregon indexes, and B, D, E as columns. Now if we execute DF1 plus DF2, okay, what will happen is basically it will go both column wise and index wise. Okay, it will check both column wise and index wise. So how the values will be, like say for Colorado, it will be null, 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 because Colorado index is there in DF1, but it is not there in DF2. Okay, that's why for Colorado index, all values in data frame 2 will be null. So these values for Colorado row, these values plus null values from DF2 will be creating say null values. Okay, so null, 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 null. And similarly for, so what is happening is we are taking addition, right? So B, C, D, E, 4 columns will be generated. B, C, D, and E. Okay. So for Ohio, let's see how it happens. For Ohio, so values for Ohio row and column B. So so 0 plus 3 is 3. So Ohio C index is available in data frame 1, but C index is not available in data frame 2. That's why the value will be for C like value plus null value from DF2. So C null value. For D and Ohio, for D and Ohio, D is a common column, right? So D and Ohio will be 2 plus D and Ohio will be 4. 2 plus 4. So for D column, it will be 6. Okay. For E, there is no value for Ohio in DF1. So null value plus 5. Null value plus 5 will be 6 for row and E column. Similarly, for Oregon, all the columns, Oregon is available in data frame 2, but it's not available in data frame 1. I mean, the index itself is not available. So what will happen is for B, C, D, E, these values will be null values from data frame 1 plus some value from data frame 2. So will be null value again. So Oregon all will be null value. Okay. And what about Texas? Texas will be like say for BD column it will be taking addition, and for CE column it will be null value. Texas BD column will be taking summation of value from DF1 and DF2, and for CE column it's uncommon columns, it will be null value. As I mentioned, like for data frame, it checks by both rows and columns. If values are available in both row and column for the specific index, then the values will be summed. Otherwise, it will be null value. And for it, UTA, see, UTA is not there in data frame 1, but it's there in data frame 2. So all values will be null. So null, 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 null. Right? Clear? You can write in chat box.
Yes. Yeah.
Yes.
Okay. Okay. Now let's say it is short data frame like df1 equal to pd dot data frame a column a. So I'm defining in dictionary. If you define in dictionary, it will be key value pair. So a will be column and these will be values 1, 2, and df2 b will be column and 3, 4 will be values. So like this one is the matrix like a column and b column. Now if we do df1 minus df2, okay. So these are all null values because A index is present in df1 and B index is present in, sorry, A column is present in df1 and B column is present in df2. So no column is common. That's why minus will be creating all null values A, B, and B, right? Got it, right? As I mentioned, like for data frame, it will check both column level as well as index level. So here columns itself are uncommon, totally uncommon. So obviously it will be creating all null values. And if you do df1 dot add, similarly, it will be creating all null values because column itself are uncommon. Okay. Now how to forcefully get some values? Okay, and execute the operation. So df1 dot add df2. If I mention field underscore value equal to 0, field underscore value equal to 0 means it will be wherever null values are there, it will be getting 0 plus those, and the values will be there. So 1, 2, 3, 4. Okay. So for a column, I'm getting elements from df1, but for a column from df2, I'm not getting any value, right? So what it is going to replace is the null value from df2, it will be replacing by 0. So 1 plus 0 equal to 1, 2 plus 0 equal to 2. Similarly, for df2, it will be 3 plus 0 equal to 3, 4 plus 0 equal to 4, because we have replaced the null values of the other matrix or say other row, other column as 0. That's why it is working like this. So df1 dot add df2 field underscore value equal to 0 will give me values like 1, 2, 3, 4. Got it? Clear? This is like filling null value. Okay. Okay.
Yes.
What will happen if I put fill value equal to 2? Who can tell me? What is if I use fill value equal to
3,
2?
5, 4, 6.
Let's see. You got the logic, right?
Yes.
Good. All of you, hopefully. So what it is, earlier I used 0, right? So 0, when I put in, I'm replacing the null values as 0. But if I put fill value equal to 2, I'm replacing the null values by 2. So it will be like 1 plus 2, 3, 2 plus 2,
2 plus
4,
4,
then 3 plus
3 plus
2,
5, 3
5,
plus
and
2,
then
and
4
4
plus 2.
plus 2.
That's why it is 3, 5, 4. 3, 4, 5, 6. Okay, so good. Uh, we have covered some initial arithmetic operations. Now, let's say we want to use function. Okay, um, there are some good features in Python, and using that you can create functions, create some operations within rows or within columns, or for all the elements of a series, all the elements of a data frame, and so on. So let's see how to do that. So df, we are going to create a data frame equal to pd.dataframe np.random.randn. Okay, so this is like draw random numbers from 0 to 1. Okay, 4 comma 3, 4 rows, 3 columns, and columns naming is bde, index equal to Utah, Ohio, Texas, and Florida. Right, so it is drawing random numbers, and then it is going to create 4 cross 3 matrix, and then columns will be bde, index will be this one. So let's execute. Right, these are all random numbers. As we mentioned that, okay, we'll create random, I mean, we'll generate random numbers and then we'll convert to this matrix. So now, suppose I want to have absolute values of all this, I mean, of this data frame. All the values should come as absolute value. The formula is like np.abs df. This np is coming from numpy. np.abs of df will give me all absolute values. Here, no more negative values, right? All values have been converted to positive. Now, suppose I want to create some operation using lambda function. So this lambda function is very important. How it works is like we're going to define, say, f. Okay, f is the function equal to lambda of x such that lambda of x is like lambda x function or say f of x function. So lambda x such that x dot max minus x dot min. So what I'm going to define is lambda of an object. Okay, take object dot max. You know object dot max means it will return maximum number or value from this object, minus take minimum of the elements from the object x. So this x has no relation to this df. I'm just creating a general lambda function and for this general object, right? So you got it right, how to create this function, define this function. Once we define this function, then we can apply within df directly. So how to apply? So this df, I mean this df original, this is we used in the abs, right? And this is the original matrix, original data frame. So np dot abs, sorry, I mean df dot apply f, df dot apply of f, this function. So what I am going to do is I am saying that, okay, apply f function to this data frame. Apply f function to this data frame. Okay, so what it will do is for all the columns, okay, for all the columns, it will take the maximum minus minimum and then it will show the output. So let's see. Check it. For column B, the maximum value is 1.4. This one is maximum value and minus minimum value. Minus minimum value is this one. So what will happen? 1.43 minus of minus, that means plus 1.43 plus 0.179. So which will be 1.61. Okay. Same for D. It will check max and minimum. For D column, max is 0.89 and minimum is minus 0.59. So 0.89 minus of minus 0.59 is 0.89 plus 0.59. So which will be 1.49. Similarly for E, the max value is 1.44 and the mean value is minus 1.04. So 1.44 minus of minus 1.04 is plus. So 1.446 plus 1.04 will be giving me 2.489759. Sorry. So got it right, how it works. Clear, everybody? Any question? You can write in chat box if it is clear. Hello. Okay.
Yes.
Okay. So again, we are going to create a lambda function of an object such that take something. Here I am using max dot mean. I mean max minus mean. So x dot max minus x dot mean, and we are storing that value in f. Okay, and here we are applying that f function to the df. That's how we are getting for each column. It will take max minus mean, and then that will be the output for b, for d, for e. Okay, that's all about lambda function. And then suppose we want to create the same operation row wise. Okay, here we have seen that it came column wise. What will be row wise? You all know axis equal to columns or axis equal to 1, axis equal to columns or axis equal to 1 give me row wise operations. So df dot apply again a function comma axis equal to 1. This will be giving me outputs row wise. So uta is highest value is 1.44 and lowest value is 0.38. So 1.446 minus 0.38 will be the output, which is 1.05. For Ohio, maximum number is minus 0.08, uh, and minimum is minus 1 point. So remember, minus is this is the maximum. Okay, so minus 0.0 is greater than minus 1.04. So maximum is minus 0.089763. Minus this is the minimum value. So 1.04. That means minus 0.089 plus 1.04. So which will be 0.595. And similarly for Texas and Oregon. I'm not repeating. Hope you understood, right? Clear? This is row wise operations. So whatever x dot max minus x dot mean we did earlier for all the columns, the same operation will be executed row wise this time because I have defined axis equal to 1 or axis equal to columns. Okay, here I have mentioned also. So df dot apply if axis equal to columns will give me the uh, same values. Okay, got it? 1.05, 1.05, 0.95, because it's just we are changing the script. Okay, x is equal to columns inside quotation works like x is equal to 1. Okay, yeah. Now let's say we want to create a function. Okay, this time let's not use a lambda function, but this time let's create some user defined function. Okay, so what we are going to do is def f of x. This function we are going to create f of x again on object. Okay, return minimum value, maximum value, average value, right? And I'm going to name those values like mean value. I want to put for minimum value, max value. I mean max row name. I want to put for maximum value. Mean row name. I want to put for minimum average value, right? So and then I'm going to create a series because I want to print the output in the series as a series. So x dot mean, x is object, x dot max and x dot mean, I mean average, and index equal to mean, max, and mean, right? So if I want now to apply this function to data from df, what I need to do is df dot apply if. So here I'm not using lambda, but we are going to create a function, user defined function. And if I do this, okay, so what it does is for all column, it is going to give me the minimum value. Remember for B column, it was minus 0.178871, which one was the minimum one, and the maximum value was 1.439812. And average of all the four elements, like four, yes, 1, 2, 3, 4. Yeah, four element is like this plus this plus this plus this by 4, because 4 number of observations. For D column, average will be this plus this plus this plus this by 4. For E column, average will be this plus this plus this plus this by 4. Okay, right? So if I execute it, It gives me mean, max, and mean row, which is coming from this index. Okay, and BDE column. For BDE column, I am getting minimum value, maximum value, and average value. Minimum value, maximum value, average value. Same for D. Minimum value is minus 0.59, maximum value is 0.89, and average value is 0.045947. And for E column, minimum is minus 1.04, max is 1.44, and average is minus 0.02. Right? Got it? So this is how we return. We can return multiple values, and we can apply the same function for DF directly. Okay. Now let's say this we did by column wise, right? What to be done if we want to execute this same operation for row wise? Everything will be same except x is equal to 1 here. Okay, df dot apply f comma x is equal to 1 or x is equal to inside quotation single quote columns. So let's see. So define f of x, return pd dot series x dot mean, x dot max, x dot mean, right? Index equal to mean, max, and mean. So df dot apply if comma x is equal to 1. This gives me these values by row wise. So let's see. So row wise, these were the rows: Utah, Ohio, Texas, Oregon, and mean, max, mean will be the columns now because I wanted row wise. So for each row, I'm going to get minimum value, maximum value, and average value. So this is for Utah. 0.38 is the minimum, 1.44 is the maximum, and so on. For Ohio, minimum, maximum, average. Texas, this one, minimum, maximum, average. For Oregon, minimum, maximum, average. Right? Got it? Clear? You can write in chat box if it is clear. Things are clear, right? Okay, so good. Now let's say we want to execute the operations element wise. Okay, element wise means I want to use some function for all the elements, irrespective of columns and rows. How to do that? Suppose I want to change the format for all the elements of a data frame, of this data frame, earlier data frame. Like say we're defining the function format equal to lambda of x such that percentage point 2f. This means, okay, if I have float numbers, I'll take till 2 decimal. Percentage point 2f means I'll take till 2 decimal. Okay, and then I'm defining percentage x for for which thing I want to do it. I want to do it for percentage x. I mean, this all the elements. Okay, that's how we can create function for element wise. Now, if I apply this function to the data frame, so how to do that? Df dot apply map. Remember, earlier we were using apply for row or columns, but if we want to execute operations for element wise, you need to apply, and you need to use script function apply map, not apply. So df dot apply map, if I put format, like which format? I mean, which function? This function format. If I want to execute this now, what it will do is, remember the df data frame had some positive values and negative values, right? And it was still 6 digits, like this one, 1, 2, 3, 4, 5, 6, 6 digits. And now from this 6 digit, I converted to 2 digit, right? So for the B column, it came as 0.39. For the D column, it came as 0.90. For E column, it came as 1.45. Similarly, this one. Now, what will happen if I put 3 here, 0.3 here? It will give all the elements in 3 decimal places. Let's see how it works. So 0.387, 0.896, 1.446, and so on, right? Similarly, if you put 0.48, it will give 4 decimal places, right? So we are going back to change it to 2. Okay, got it. Now, suppose I want to apply this format to a specific column. Okay, to a specific column. So how can we do that? So df of this column, okay, df of this column or this column or this column dot map. Okay, if I going to use this function for all the elements and for a specific column, then we'll use function map. So dfe this column dot map and then format. This will change the format of all the values in E column as two decimal places. I think I did not execute it after changing. So check the E column only for E column. It came as 1.45 minus 1.040 and minus 0.59. Right? Got it clear? You can write in chat box. Okay. Now let's say we are going to sort and rank the data frames, some rows and columns, etc. Suppose we are going to create an object which is a series object, pandas series, v dot series, range 4. That means 0 to 3, right? 4 will be excluded because of close bracket and open bracket. Index equal to D, A, B, C. So for 0, the index will be D. For 1, the index will be A. For 2, index will be B, row index. And for 3 value, row index will be C. So let's execute it. Okay, so 0, 1, 2, 3. Now, if I want to, so see this index D, A, B, C is not arranged, right, in terms of ascending order. Now I want to arrange these indexes in terms of ascending order. I want to put like A, B, C, D. How to put that? I mean, how to get that? Obj, this object, dot sort underscore index. This is the syntax. Obj dot sort underscore index. If I put it, then in, it will arrange the row indexes in ascending order. So A, B, C, D. A, B, C, D. Okay. That's what how we can arrange the indexes, row indexes for a series. Now how to do that for a data frame? So df equal to pd dot data frame np dot arrange. Okay, that means 0 to 8, and then reshape 2 comma 4 matrix, index equal to 3 1 3 1 row indexes, and columns will be d a b c. So we are going to get range of numbers from 0 to 8. So 8 won't be included because close bracket, open bracket, 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. Because I have defined like get two rows, and the row names are 3 and 1, and column names are D, A, B, C, 4 column names, right? 4 column names. So D, A, B, C. So D column is 0, 4, A column is 1, 5, B column is 2, 6, and C column is 3, 7. Now if I put say df dot sort underscore index, remember this sort underscore index means it is just to sort the index, not the columns. Sorry. That's why if I use df dot sort underscore index, it will arrange the, just give me a minute. Okay, so it's I'm going to arrange the index in ascending order. So 1 3, earlier it was 3 1, remember. So 1 3, accordingly all the elements will be also arranged. I mean, for 1 it is 4 5 6 7, right? For 3 it is 0 1 2 3. And if I want to get the values uh, like say by columns, okay, df dot sort index underscore index axis equal to 1. This is how we uh, arrange the columns in increasing order. So columns were earlier D, A, B, C, right? So it will be A, B, C, D. Got it? Right? Now, if we want to say arrange in descending order, okay, if we want to arrange in descending order, what we are going to do is df dot sort underscore index axis equal to 1. That means column wise. But here we are putting ascending equal to false. So it should be descending. So if I execute this, descending is obviously D, C, B, A, right? So D, C, B, A. This is in descending order, and this is in descending order because we have put ascending equal to false. Okay. Now let's say we want to sort by values. Okay. I mean sort the values by say B column. Okay. So sorting by values, df dot sort underscore values by equal to b. By which column? B column. So it will first sort the values by which is 2, 6, and accordingly all values will be arranged. Okay. You are unable to understand because it's already in ascending order. It would have been 6 and 2, then it would have arranged in 2 and 6 kind of, right? And accordingly all the values of other columns also will be arranged. So that's how you can arrange the values by a column. df dot sort underscore values by equal to column name. This is the column name. Okay. Now let's say we are going to create a series again. I mean, just to show you 4, 7, minus 3, 2, and this is the object. Okay. Earlier we have seen like how to arrange the index numbers. Now we are going to see like how to sort the values. Okay. So the command is like obj dot sort underscore values. This is no more sort underscore index. Now we are putting sort underscore values. So so this will be ascending the values in increasing order, like minus 3, then 2, then 4, then 7. Minus 3, 3, then 2, then 4, then 7. Okay. Now let's say uh, we are going to create an object having some null values also. So obj equal to pd dot series for np dot none. So that's how you can get, I mean, you can define a null value. np dot none. Okay, that's for null value. So 4 comma np dot null, none, 7, and then comma np dot none, minus 3, 2. So these two positions have null values. So let's create this object. 4 null value, 7 null value, minus 3 2 value. That's how we created, right? And if I put df dot sort underscore values, let's see what happens. Okay. So check like it is first going to give me the last list element, so minus 3, then 2, then 4, then 7, and then all the null values will come. So remember, if we have null values, those null values will be coming lastly, okay, not as the first. Because null values does not have meaning. I mean, it's purely null. So that's why null values will come at the last. Now all other elements will be arranged in ascending order. So minus 3, 2, 4, 7. Got it? Now let's say we want to do the same operation for a data frame like df equal to pd dot data frame b column. So this is again a dictionary. This is key value pair, one key value pair. This is another key value pair. That means that I'm going to create two columns b and a for this data frame, and b column values will be 4, 7, minus 3, 2, and a column values will be 0, 1, 0, 1, right? If I create it df, so b column is 4, 7, minus 3, 2, a column is 0, 1, 0, 1. And now I want to say increase sort the values by column B. Okay, so df dot sort underscore values sorry by B. Here you will understand how things are happening. So just give me a few seconds. So here how things will happen is first it will sort the values of column B. Okay, check this. Column B is minus 3, 2, 4, 7. Minus 3, 2, 4, 7. And for minus 3, the value for A is 0. So automatically the A column will be arranged also, right? So A column minus 3, 0, 2, 1, 7, sorry, 4, 0, and then 7, 1, right? So that's how we can sort the values by a column. df dot sort underscore values by equal to column. Okay. Now let's say we want to sort the values by A and B together. I mean, first by A and then B. How it works? First by A and then B. So check. Like first it will like say I have multiple values for A, right? So first it will be 0, 0, 1, 1. Now for 0, 0 also it will be sorting the column B first. So for 0, 0 it will be minus 3 and 4, and for 1, 1 it will be 2 and 7, right? Got it? So first I'm going to sort the values by A and then going to sort by column B. So how I'm putting it, df dot sort underscore values by equal to in a list. So I told you repeated times, multiple times, that if you need to define more than two columns, then you need to define that inside a list. So earlier we did not use list, right? See, by equal to means directly, but since we are going to use two columns, so by equal to in a list, inside a list, a and b. So that's how it works. Okay. Now let's say we are going to create this object period of series 7 comma minus 7, 7 comma minus 5, 74204. This is the object. Now rank it. So rank means I will get the rank values of these columns of this, I mean, of these values. Okay. Okay. So now check this. There is one concept called tied rank. Okay. Tied rank works when there are there are values which are equal. Okay. Suppose 4 and 4. Okay. This is equal values, right? So how it will ranking is obj.rank. If I execute it, my first value is minus 5, which will get one rank. Okay, so one rank. Then my uh, next value is 0. So the 0 is only 1, so it will get 2 rank. 0 is getting 2 rank. After that, the value is 2. So 2 is getting 3 rank, right? 3 rank. But when you are when you are moving forward, like say 4, ideally 4 should get 4 rank, but there are 4 values 2 times. Okay, so this is a tied rank actually. So how tied rank works is it should be 4 and then it should be 5. So but for tied rank, it is generally 4 plus 5 by 2. So for both these values, we take 4.5 ranking instead of 4 and 5 ranking. So that's why this is also 4.5 ranking. I mean, this third index value and sixth index value is also 4.5 rating, right? Then after 4 5, the next rank will be 6. So like 7, right? 7 value is again common, I mean, repeated. So 7 is also case of tied rank. So like 6, after 4 5, the rank should be 6 and 7. But instead of 6 and 7, it will be average of 6 and 7. So which is 6 plus 7 by 2. So to this 7, which is index 2, we give 6.5 ranking. And to this value 0, we give 6.5 ranking, right? Got it? This is called tied rank. This works in statistics, okay? Got it? The concept of tied rank clear? Can you please write in chat box if it is
Yes.
clear? Okay. Now, if we want to say remove the tied rank, this is the command obj.rank method equal to first. Okay. So whatever values is coming in the first time, so we'll give the rank next and then next the next rank. So method equal to first. If we execute it, so remember minus 3 will get minus 5 will get one rank, 2 will get 2 rank, 0 will get, sorry, minus 5 will get 1 rank, 0 will get 2 rank, 2 will get 3 rank, this 4 will get 4 rank, this 4 will get 5 rank, this 7 will get 6 rank, this 7 will get 7 rank. 1 2 3 4 5 6 7, yes, right? Check it. The 6, I told you 1 rank, then 2 rank, 3 rank, 4 rank, 5 rank, 6 rank and 7 rank, right? This remove the tied concept and it ranks whatever values are coming first, then it will get the lesser rank. I like 6 and then 7 it was value, right? So this is 7. Got it? Now let's say we want to give rank like which is maximum. Okay. Okay. So basically assign type values the maximum rank in the group. Okay. So obj.rank ascending equal to false, method equal to max is how it works is like it. Just one second. Okay. So basically first the two index, one index is minus 5, right? Okay. So it works oppositely, right? So minus 5 will be getting the 7 rank, other values will be getting the the 7 value will be getting, so it will run in the opposite direction. So 7 will get one rank, right? So 7 and 7, this should get 1 and 2 rank. But what I'm telling that, okay, within a group take the maximum rank. Maximum is 2. So this 7 and 7 will get 2 rank. Okay. Then next rank is 3, right? So 3 will be for 4. So 4 rank will be there, 4 4, because I told that take the maximum rank. So 4 4 will be assigned for 4 4, and so on. It will be reducing, and finally it will be rank for -5, which is 7 rank, right? That's how it works. So method equal to max, take the maximum rank for -5 7, and so on. Now let's say we are going to create a data frame like B column 4.37 -32, A column 0 1 0 1, C column -2 5 8, -2.5, and we are going to create B column, A column, and C column. Now if I want to generate the rank for columns, the command is df.rank x is equal to columns. Okay, so this will give me rank, like of for B column it will be -3 will be getting 1, then 2 will be getting 2, this will be getting 3, and 7 will be getting 3. So right, so one sorry, actually x is equal to columns, right? So we are getting for row wise. So 1 2 3. So this is 1, this is 2, this is 3, and for 1 this is 1, this is 2, this is 3, and so on, right? So that's all about ranking. Now let's say how to check the duplicate records. Suppose we are going to create a pandas series, obj.pd.series, range equal to range of 5, so 0 1 2 3 4. Index will be a b b c, right? Let's create it. And if I want to check the duplicate records, this is the command is underscore unique. Okay, so obj.index dot is unique. This will give me whether these indexes are unique or not. So a b b c. Check there are duplicate records, right? Duplicate indexes. So if I put is underscore unique, this will be false. If it would have been A, B, C, D, E, then this would have been true. Okay. And if I put obj is dot is unique, this goes by values. So 0, 1, 2, 3, 4, these are having all values, which is unique values, no duplicate. So obj dot is unique will give me true. Right? Got it? And as you know, like if you want to access the values of the object, this is obj dot values, right? Let's do the same operation is unique for a pandas data frame. So df equal to pd dot data frame, np dot random random 4 3, right? So we are going to create random numbers, and then we are going to convert to a 4 cross 3 matrix, and index we are defining a b b, right? Let's check. And you know already how to access the first column, df of 0, right? This is the first column. So we want to check now whether the first column is having unique values or not. So df0 dot is underscore unique. This will tell me whether first column has unique values or not. So this will be true, right? Because these are all unique values, no duplicate records. That's why df0 dot is underscore unique is giving me true. So to check whether the second column has unique values, so df1 is the second column, and then dot is unique. So let's see whether second column has unique values. This is the second column. Yes, it has also all unique elements. And similarly for 2 also. 2 is also having unique column. So df1 dot is unique should be true, and df2 dot is unique should be also true. Okay. Now, suppose we want to check whether a row has unique values. You know, like to define a row, we define iloc. So iloc is for index lock. So df dot iloc 0, this is the first row. Dot is unique. Now check it. So this row minus 0.73, minus 0.56, 1.26, these are all unique values. There is no duplicate record. That's why it will be giving true. Okay. So let's so I'm not